Okay. Start with the questions. Question number 1, question number 2, and then 5 and 6. 4 minutes only. Now the time is 7:14. And you have another few minutes more. MCQ බලපරින්න පටන් ගන්න. Do it quickly. Right, time's up. Which change would affect both value of the equilibrium constant and the proportion of ammonia present at the equilibrium constant? So the make උත්තරේට හිතන්න දෙයක් නැහැ. Kp depends only on temperature. So the answer is D. D එකේ දෙකක් තියෙනවානේ. නෑ D with B, sorry B. Only in B there's a change in temperature. Kc, Kp both depends only on temperature. In reversible reaction, what the effect of adding catalyst on the rate constant forward reaction, rate constant of the backward reaction, and the equilibrium constant? Catalyst will increase the rate of reaction. Will increase the rate of both forward and backward reaction equally. It was again Kc depends only on temperature. So answer is C. Make equation එක දුන්නේ නැද්ද? මොකද equation එක? Equation for this one is 2NO2 divided by. Okay, 4 mole of nitrogen monoxide put into NDM container, equilibrium mixture obtains 0.8 of oxygen. The equilibrium mixture contains 0.8 oxygen means, right, only 0.8 has formed. So 1.6 of this is formed and 1.6 of this reacted. So the remaining 2.4, 1.6. The good answer is this. Equation is when 4 mole of it. Which of the following which of the following statement is not correct? Not correct. Unit of Kp are ATM minus 2, ATM minus 2. Yes, that is the unit of Kp. Kp increases when temperature decreases. This is exothermic reaction. Increasing temperature will decrease the Kp. Yes. Kp increases when the pressure decreases. That's the answer. K depends only on temperature. K depends only on temperature. Okay. Last two. 3 and 4, please. In 2 minutes. Okay, yeah, with the answers, hydrogen and iodine vapor exist in equilibrium with hydrogen iodide at constant temperature in a gas cell. What will increase when the pressure is increased at the constant temperature? So you are going to increase the temperature, pressure, so the Kp no. Right, again, activation energy won't change, enthalpy change won't change. Partial pressure of hydrogen. Why the partial pressure of hydrogen increase? Partial pressure is, then why make a bulk there is no effect on pressure here because same number of gas molecules in each side. But make partial pressure of hydrogen. Partial pressure is mole fraction into total pressure. If you increase the total pressure, partial pressure will increase. So the partial pressure of hydrogen iodide will increase and also will affect to the partial pressure of H2 and I2 as well. No net effect. Everything will increase. Last one. Last one, please. Okay, nitrogen hydrogen mixture initially molar ratio 1 to 3, and then reaches equilibrium when ammonia 50% of the nitrogen has reacted. N2 right. So the reacting ratio is 1 to 3. Only 50% is reacted. So 0.5 reacted, 1.5 reacted, 1 to 3 ratio, forming 1. At equilibrium, you have 0.5, 1.5, and 1. Right? Mole fraction 3, 0.5, 1.5 over 3, and 1 over 3. And the total pressure is P, and P. Then they're asking partial pressure of the ammonia at the mixture. Answer is C. Quick calculations. Clear? Good. Okay. Now question number 7. Question number 7. Now 7 and 8, we'll do both the questions, 7 and 8. Here we go. The nitrogen and hydrogen react together to form ammonia in a reversible reaction that can reach a position of equilibrium. The equation for this reaction is given. So N2 plus 3H2, 2NH3, a fixed temperature, total pressure 5, seal vessel volume of 2, contain 1 mole of nitrogen, 2 mole of hydrogen, and 1 mole of ammonia. Calculate the value stating the units of equilibrium constant Kc for this reaction. Ru.Ba. The reactant at equilibrium reactants, products, everything is there. Nitrogen and hydrogen react to form ammonia reverse at position of equilibrium. The equation at fixed temperature and the total pressure, this seal vessel contain this. That's it. This is equilibrium. So equilibrium moles. Right? Then we can come to the concentration. Concentration is 1 divided by 2. Here 2 divided by 2. And here 1 divided by 2. Volume is 20. Sorry. 20. So we have to write the Kc for 1 mark for writing Kc expression. NH3 square divided by N2 and H2 to the power 3, and you can simply substitute the values. Also, so the Kc value is 1000, it seems, and the unit mole -2 dm6. Try එක ලකුණු 5ක් දෙන්නේ. I doubt why. Finish copying now. That's the reason for giving 5 marks for Bala. අదే කියලා. හරි කලබල වෙන්න එපා කලබල වෙන්න. අනේ මේ බල ලකුණු දීලා තියෙන හරි අසාධාරණ. very unfair. ඒ 1000 නෙමෙයි. නියෝලා 50. උඩ. මෙතන වැරදි නේද? මේගොල්ලෝ 50 තමයිනේ. මෙතන මේ working එකේ වැරද්ද. නේ අනේ. ඉතින් ලකුණු පාම ගන්න තිබ්බ chance එක නැති. Right. Next question. They might ask to calculate the Kp. Yes. So again, we can write the expression. N2 plus 3H2 2 into 3. So put here you have 1 to 1 mole fraction. 1 divided by 4. ඔයාලට මේක ටේබල් එක ලියන්න පුළුවන් නේ අවුලක් නැහැ. ඉන්ඩෙක්ස් හැමීම mole fraction and the partial pressure. Total pressure is 5, I think. Okay? It's 5, yes. Right. Then you have you can calculate the Kp. Kp and Kp is the same level. When you are writing Kp, you should not use the square bracket. The partial pressure of NH3 to the power T and partial pressure of N2. Like that. But B must be there. Like B stands for partial pressure. So what is the unit and the values, please? That she has some. Okay. Right? So, what is the answer? Unit 80 minus 2. Make a 12. 80 minus 2 are there. Okay. That make the decimal places. 0.08 ATM minus 2. That time finally correct. Yes. Question number 8, and we'll finish with question number 8. Yes. Please go to the question number 8. KP expression. Units will be ATA. Explain in terms of equilibrium expression. Okay, effect on position of equilibrium. Increase in pressure at constant temperature. Therefore, you have to think about the QP. P is equals PCl2 into P PCl3 divided by P PCl5 and PCl5 of partial pressure of PCl. So the again you can make it relate to mole fraction, and it's to P total. Make that idea, no? Yola, Nimesh. Again, partial pressure of Cl2, you can write it as mole fraction of Cl2 into total pressure. Partial pressure of PCl3, you can write as mole fraction of PCl3 into total pressure. Mole fraction. Again, partial pressure of PCl5, you can write it as mole fraction of PCl5 into total pressure. If we separate these mole fraction terms, right, you can write this QP as mole fraction into mole fraction of Cl2 into mole fraction of PCl3 divided by mole fraction of PCl5 into total pressure, because total pressure. Considering this one as a constant value, you can get this now. QP is proportionate to total pressure. Okay. So increase in pressure will increase the QP. Again, you have to derive it. So increase in pressure will increase the QP. Therefore, QP will be greater than KP. Therefore, position of the equilibrium will shift to the left-hand side. You have decreased the QP now until QP equals KP. Right. मैंने उत्तर दिया था मीट वाला मंकी को देर ना let's go to the part C then. And a different question there, right? Relationship between Kc Kp is given by the expression this, where T is the absolute temperature, which is in Kelvin, and N is the number of moles from the reactants to product. Calculate the Kc. So N is 1 here. One reactant, 2 products. Difference is 1. So you have just simply substitute the values. Yes. And then reaction PCl5 gives you PCl3 plus Cl2. No? Number of products 2, number of reactants 1. Difference is 1. Maybe unseen equation can be given. There you have to use your knowledge.
With the you go there, you come sample papers. Practice. Yes, mark anyway.
Get it down. Yes.
What Equilibria Last?
तो एग्जाम में करना ना कैमरा का ऑन करो और ये तो पाया ही ना पाया है तो ये लग रहा
8 marks, 80.
90 minutes okay within 80 minutes you have to finish कैमरा ऑन करना था डायनो पार्टिंग that's it okay so fix your camera sir तीन पास में तुम्हारा जाएगा maybe ना पास में बैठ okay question number 9 हर नाम याद कर लीजिए कर
Aku ada buat terapi loh.
hari ada patang ini ada to
Itu dulu ada.
hari okay we can finish it do the question number 9 quickly so I win it
नहीं ना. Dia ada. Dia ada ini.
okay please do the question number 9 Right.
Oh,
Right. Expression for Kp is P to partial pressure of R, partial pressure of P squared into partial pressure of Q. That is the expression. Give the units. ATM minus 2. During the initial research, the chemists carried out several experiments at all 500 ATM pressure using the mixtures of P and Q, starting with 2 moles of P and 1 mole of Q. In each case, they allowed the reaction mixture to reach equilibrium before determining the percentage of Q converted. The table gives the results of the two experiments. Calculate the Kp for experiment 1. So the percentage of Q converted is 50%. So the equation is 2P plus Q gives you R. Using starting with 2 moles of P and 1 mole of Q. So 50% of Q reacted means 0.5 reacted. 1 reacted, forming 0.5. So the equilibrium moles will be 1, 0.5 and 0.5. Hey, initial reacted and formed equilibrium. Subtract. Then I will directly go to the partial pressure. Mole fraction is total moles is 2 into partial pressure is 500. Sorry, total pressure is 500. 0.5 total moles is 2 into 500. That gives the partial pressure again. And then 0.5 by 2 into partial pressure 500. So you have the partial pressure values. You can substitute this experiment and you can get the Kp value. What is the Kp value? And molar ratio. No? When you react, you have to think about the molar ratio. Here 2 to 1 to 1. Can someone tell me the answer now? Kp is then 5 into 10 to the power of minus 3 ATM minus 2. So, okay. Other things. Yeah, 1.6 into 10 to the power minus 5. Now they said 50% of Q reacted. 50% means 0.5 reacted. So the Q stoichiometry is 1. Mea 2. So mea 0.5 na mea 0.5 into 2. Deduce the conditions of temperature and pressure that would give the highest yield of R. When you increase the temperature, percentage conversion increases. Did you see that? When you increase the temperature, percentage conversion also increases. That means forward reaction is endothermic. So high temperature will give the highest yield of R, and left hand side 3 gas molecule, right hand side 1 gas molecule. So high pressure also gives the highest yield. Explain why the conditions we have suggested in part 2 may be different from those used in industry. Yes, to generate high temperature, you need large amount of energy. So moderately high temperature will be used. To generate high pressure, again you need high energy, and you need to use special containers to withstand high pressure. So that is expensive. Okay. Right.